In this video, I'm going to present a very short introduction to MATLAB that you might require to implement algorithms for this course. This is essentially for the people who do not know MATLAB at all. So first, to download the software from IPC, you can go to this link, ipcservices.bits-pilani.ac.in, and we log into software repository using the bits account. So you'll see MATLAB here. You can download depending on your operating system and install the software. After installing, when you run it, you'll see a screen like this. So this place is where we'll be typing all our commands. It's called command window. This is the current folder, so this will precisely tell you your location at this point in time. And workspace is going to show you all the variables that you have been defined. Now, each variable in MATLAB is stored as a matrix. For example, if I write a equals to 2, it will be stored as a 1 by 1 matrix whose entry is 2. Now, if we want to put any matrix in it, so let us say a 3 by 3 matrix. So let's say first row is 1, 5, minus 1. So this will constitute the first row. If I want to go to the next row, so it will be 2, 3, 4. Let's say this, and then last row minus 1, 2, 8. So this will be a 3 by 3 matrix whose first row is 1, 5, minus 1, second row is 2, 3, 4, third row is minus 1, 2, 8. So this semicolon breaks a row. So as you see, it will be displayed here. Now instead of this, if we put a semicolon over here, we will be storing the matrix, but it is not being displayed here. Now, to go to the previous commands that you have typed, you can use your arrow buttons to visit those commands. So we had recently used these three commands. So these are being displayed over here. Now, few usual operations. So if we write down another matrix, so let us say 1, 0, 2, 3, 4, 5. 2 minus 1. So this is second matrix B. This semicolon will not show this matrix on this command window. If I want to add them, we can simply use A plus B. We'll get the result. If you want to multiply them, A star B. If you want to, let's say, invert a matrix, so you can use INVA, or alternatively A raised to minus 1. So this is going to give you inverse of this matrix. Similarly, you can multiply a matrix by scalar, subtract matrices, and so on. A few other common operations for matrices that we will require would be rank of matrix. This will be extremely important. So command is simply rank of A. It is going to give you the rank, determinant of A, so DETA, that's minus 91 for this particular matrix. Now, suppose you want to know size of a particular matrix, you write size of A. So this is number of rows, this is number of columns. Let's say you want to convert a matrix into reduced row echelon form. So command is RREF, and since matrix is invertible, so its RREF should have been an identity matrix, which you see to be the case. Now, if you want to, let's say, compute eigenvalues of A, so you write this command eiga. This is going to give you the eigenvalues for this matrix. Now, if you also want to find out the corresponding eigenvectors, there will be two outputs. So we can write this as AB equals to eiga. So what it is going to do is it is going to give you two outputs. One is a small a, another one is a small b. So small b contains all the eigenvalues represented as diagonal elements. And first column is eigenvector corresponding to this first eigenvalue, minus 2.0391. Second column is eigenvector corresponding to second eigenvalue. And the third column is eigenvector corresponding to this third eigenvalue. Now let us say I want to clear whatever is written on my screen. The command is CLC, so it will clear whatever I have written. So it has just cleared my screen, but all the variables are still there. So you can see small a, capital A, small b, capital B that we had defined earlier are there. Okay, so we had entered this matrix A. Now suppose I want to extract its second column. So to do that, and let's say I want to store that in another matrix called C. So what I want to do is I want to get all rows of A and its second column. So uh, I'll leave this as empty, comma, colon, 2. So this is going to give me, sorry, comma should be after colon. So yeah. So as you see, the second column of A was 532. So to access that, this is the command. So I leave row space empty. So that means I'm considering all rows and second column. Equivalently, if I want to access a particular row, so now let's say I want to access the second row. So second row, I want to consider all columns. So I leave this column thing empty. So 2 comma column means I'm going to get all columns of the second row. Now there are a few more commands which we are going to use. So if I use this command max of A, this is going to give me column wise maximum of our matrix A. So if you see, this was our matrix A. If you look at the first column, its maximum was 2. So this is 2. Second column maximum was 5, and for third column maximum was 8. So this is showing you 8. Now if I use maximum command with these two outputs C and D, this is what I'll get. So this was my matrix A. When I use this command with two outputs C and D, this is what I get as C, and this is what I get as D. So C is a vector which contains maximum elements. So for first column it was 2, second column it was 5, and the third column it was 8. And D gives us the position of the maximum element. So for first column, maximum element was in the second row, so 2. For second column, it was in the first row, so 1. And for the last column, it was in the third row, so 3. Uh, another another command. So similarly, very similar to max, min command can be used to find out minimum. Another useful thing could be finding out roots of a polynomial. So let us say my polynomial was x square minus 3x plus 2. So x square coefficient is 1, minus 3x coefficient is minus 2, and 2. So this will be the coefficient. So I'm storing coefficient of x square, x, and x raised to 0 in a vector. And then I can find out roots of this vector p. It is going to give me roots of the corresponding polynomial, which are 2 comma 1. Now I've already told you what CLC does. It clears my screen, but all the variables are still there. If you want to clear the variables as well, so you put clear all. Now you see from your workspace, everything is gone. Uh, Finally, I'll explain how to use loops in MATLAB, because this is again would be a very important thing to implement optimization algorithm. So let's say uh, I write a for loop. So for I equals to 1 to, let's say I'm going up to 3. Then I'm nesting another loop for j equals to 1. Let's say I'm going up to 4. So what I'm trying to do here is now is I'm trying to create a matrix Aij whose entries are of the form I plus j. So I write A I comma j equals to I plus j. I put a semicolon so that I don't see all the entries, and then I'll have to end these loops. So one loop has ended and another loop has ended. Now, if I want to see the matrix A, I simply type A here, and this is the matrix, right? A11 is 2, A12 is 3, and so on. So entries are of the form I plus j. So in this manner, for loop can be used. We want to see the conditional statements uh, if, and okay, maybe before that. So everything that we are writing on command window can be written in a script as well, so that you can save that file and use it later on as well. So we go to this new script. So I type whatever I want here, then I save it somewhere. So let me save it here only. Let me call it trial. If I want to compile it, so this is the button run. So when I, okay, so I've misspelled. Okay, that doesn't matter. So uh, okay, so let me add one more line. So here I've computed this matrix A. I'm not displaying individual entries. So I've written, I put the semicolon here. Now in the end, if I want to display this matrix, for that I can either simply type A or maybe show you one more feature. So say the matrix is, so this will appear as text and then I can write A. So now when I, oh, I forgot to close this bracket. So this is your matrix. If you want to maximize this command window, you can click here and maximize it. If you want to go back to the previous position, you can restore. Now let's maybe create another matrix. Instead of I plus j, I'm writing I minus j. So I have this matrix. Now I wanted to explain if the conditional statements if else. So let us say I want to find out the number of negative and non-negative elements of this matrix capital A that we have obtained here. So for this purpose, let me start two counters, k equals to 0, l equals to 0, and let me start loops for I equals to 1, 2, 3, or j equals to 1, 2, 4. What I want to see is if ai comma j is greater than equals to 0, let's say I'm increasing a by 1, else, so other case would be aij is less than 0. Let us say I'm increasing the counter L. Then first I end this if statement, then I end this first for loop, and then I end this second for loop. So this is done. So k is going to give me number of non-negative elements, and L is going to give me number of positive elements. Sorry, number of negative elements. So when I compile this, so this code has run. If I put k, this is 6. If I put L, this is also 6. So there are 6 positive as well as negative elements. So negative elements you can count 1, 2, 3, 4, 5, 6, and the other condition was non-negative. So 3 zeros and then 3 positive elements. So these are total 6. Uh, Finally, I'll also like to explain how to write your functions. So there are some inbuilt functions like max, min, determinant, rank, etc. You can create your own customized functions as well. And for that, you open a new script file. And let us say I want to write a function to solve a system of linear equations. So it is going to take two inputs, one a matrix A and other the right hand side vector B. So the way you write a function is, so start with function. This is your output X, and this will be, let me call my function as solution. So what's happening here is solution is the name of function. It takes two input. One will be capital A, another one will be small b. So these two inputs will be there, and it is going to give you output called X. So to compute X, what we need to do is X will be A inverse B. So I'm assuming my matrix is invertible. If you want to check that as well, you can put if-else condition to first verify whether matrix is invertible or not before you compute this solution. And finally, let me display the solution is, and then you will see the solution. Okay, so now I have to save this file, and remember the name of the file should be same as the name of the function. So it is solution. So I'll save it. Another thing, if we want to use this function, the current folder should be same as okay, the place where you have saved this function file should be same as the current folder. If you're confused, just click run once. It is going to show you an error because you can't compile a solution file, but it will change your folder to the current one. Now, if I want to use this function, I need two inputs. So I need a square matrix because I want to invert it. So let us take the first matrix which we took. So 1, 5, -1, then 2, 3, 4, then -1, 2, 8. And then I choose a vector, let us say 1, -1, 3. Some error is there. So I did not see. Now, if I want to use this function, so solution, it is going to take two inputs, A comma B, and it is going to give you this output. So solution is if you're denoting your variables y, x, y, z, so x is this, y is this, and z is this. So I guess this much introduction is enough since you are familiar with coding, so you know how to write a code. I've explained the basic syntax that is there in MATLAB, and if you want any help, so that okay, that's easily available on Google. So if you are not sure about a particular command, you can Google it. If you know the precise command, you are not sure how to use it, you can simply write help with the command name. Let us say I want help with size. So it is going to show you the document with example here. So in how many ways this command size can be used. So there are various ways in which this command can be used. So if you know the precise command, you can directly get help from here. If you are not sure about a precise command, please feel free to use Google. So let's stop with this.